If you freeze a fluid dynamics simulation, the water resolves into a grid of calculated variables. Physics has spent the last century breaking reality down. Below the level of matter, below quarks and quantum fields, we find data. The physical universe operates as a self-computing system, where everything we measure is the output of an underlying code. In 1989, physicist John Wheeler proposed that every particle and every field derives its existence entirely from answers to binary questions. He called this it from bit. The information is the primary substance. The particle is merely how that information presents itself to an observer. This aligns with Claude Shannon's proof that information has a strict, measurable geometry. It takes up space and requires energy to process. Later research into black holes and thermodynamics confirmed that Shannon's math dictates the limits of the cosmos. Erasing a single bit of information costs a specific, irreducible amount of heat, and the data capacity of a region is strictly capped by the surface area of its boundary. If the universe is a processing engine, it requires a physical substrate. Physics still needs to identify the cosmic hard drive where this data is stored, the operations that manage it, and the mechanism that protects it from thermodynamic collapse. The observer-dependent theory of everything, or ODTOE, identifies this substrate as a multidimensional geometry. This wireframe models a state space where every potential configuration of the universe is written as a point on a continuous surface. The durability of this storage medium depends on its proportions. By scaling the torus exactly to the golden ratio, or phi, the geometry creates a path that never repeats and never crosses itself. This proportion is dictated by the KAM theorem, which determines the stability of orbiting systems. Because phi is the most irrational number, a ph-Torus is the most stable sheet possible against chaos. When energy waves strike the surface, the mathematical lines absorb the impact without breaking the data trajectory. This geometry acts as the universe's indestructible hardware. The foundational code is protected by the math itself, ensuring that information cannot be corrupted by external perturbations. Hardware requires an instruction set. Every elementary interaction follows a protocol similar to computer code, where particles act as execution commands. A photon exchange functions as a read operation. Electromagnetic interaction copies the state of a source without modifying it. An electron absorbs a photon, receives data about another charge, and remains an electron, transferring information at the speed of light without changing the identity of the participants. Transmuting a particle requires a write operation. The weak charged interaction, the W boson, is the only mechanism in nature that can overwrite a particle's fundamental role. During beta decay, it converts a neutron into a proton, physically changing the identity of the data at that coordinate. This operation is energetically expensive. The W boson is roughly 80 times heavier than a proton because writing a new identity requires an immense concentration of energy. We see the scale of that energy in the massive, multi-layered hardware of the CMS detector, which is designed to capture these high-cost transmutations. These interactions represent a highly regulated system of data entry, where the nature of the force determines the energetic price of the operation. The Z boson performs a verify operation. It acts as a cosmic checksum, auditing the coherence of the information loop. It interacts with particles to ensure the system is stable, but like a parity check in a computer, it does so without altering their identity. For these operations to remain consistent across different scales, the system needs a clock bus. Gravity performs this sync operation. Across the 4-kilometer length of the LIGO detector, we measure gravitational waves as oscillations that link every level of the recursive universe. Gravity synchronizes the tick frequency of the subatomic scale with the macroscopic, ensuring the code remains coherent across all dimensions. The standard model of physics is a complete software architecture. It provides the protocols for reading, writing, and verifying the data that constitutes our reality. Reality is structured as an infinite recursion of these tori. A central level of reality sits between smaller subatomic levels nested inside it and larger macroscopic levels encompassing it. Information access across these levels is limited by the discernibility horizon, or D-Prot. As you look away from our specific level, visibility decays by the golden ratio. This results in a roughly 62% drop in information clarity for every level of recursion we move through. We have full access to our own physical plane, but the data from subatomic quarks or massive ecosystems is inherently blurry. We aren't seeing a lack of detail, we are seeing the geometric attenuation of a network barrier. Detectors like Super Kamiokande attempt to read what leaks through this barrier. By capturing neutrinos, we are monitoring the gaps in the information loop. These particles are the byproducts of the cosmic software's processing cycles, offering a rare look at the data moving through the levels below us. The mysteries of the very small and the very large are the results of this mathematical encryption. Our perspective is limited by the specific window we occupy in the stack. If we calculate the Shannon entropy for the distribution of matter and energy in this toroidal geometry, we find the system operates at 68.68% efficiency. In ODTO, the missing information, the gap between the system's actual state and its maximum capacity, manifests as an expansionary pressure. Cosmologists measure this exact pressure as dark energy, which accounts for approximately 68.8% of the universe. The expansion of the cosmos is the physical measure of its informational incompleteness. The remaining 31% is the specific amount of informational redundancy required by the KAM theorem. For the ph-Torus to remain stable against chaos, it cannot be fully saturated with data. This buffer is the structural insurance policy that prevents perturbations from collapsing the orbits of reality into total entropy. The universe is not an expanse of matter floating in a void. It is a stable, self-computing architecture that is actively reading, writing, and verifying its own existence through the geometry of the golden ratio.